And that is where my camera stopped recording because it ran out of memory, because I stupidly didn't check for space on the SD card. So unfortunately this will not be a build video, but instead a spoken one in which I explain you how I built this machine. First of all, I'd like to state that this machine cost me almost nothing to make. I built this disc sander completely out of recycled materials, from the motor to the disc to the table, the work table. So the only thing I had to buy was this capacitor. This capacitor is supposed to be mounted inside there, because this is what makes the motor start spinning at power up. So I didn't mount this into the motor because I just haven't figured out how to wire it properly to the motor. You know, it seems like one of those very simple things that anybody is able to make, except for me. So if there's anybody out there willing to give a hand and explain me how to use this damn thing, that would be much appreciated. I'd be very grateful. So that said, let me open this thing up and explain a little bit the problems I had to face and also the solutions I came up with. So the first thing you notice, of course, is the big disc installed right here. This disc is a 30 centimeters diameter disc, or 12 inches diameter disc for our American friends out there. I cut this disc with my jigsaw from a reclaimed particle board shelf. This one. This is the leftover shelf. And the first thing I had to decide was the size of this disc. I originally intended to make a smaller machine, for example a 15 or 20 centimeters in diameter disc, but then I thought that a 30 centimeters disc would have been more useful, so I decided to make it bigger. Then I had to face another problem. Let me open this and spin it around. So as you can see, the heart of this machine is the motor. This motor came from a washing machine a friend of mine had broke down, and she was very happy to give this motor to me, and as soon as I had it in mind, I knew I would have used it to make this disc sander. So the first problem I had to face was raise the motor up, because being the disc 30 centimeters in diameter, this means that the center of the motor and the shaft has to be at least 15 centimeters above the base. So I had to figure out a way to prop the motor up. Originally I thought to use a pallet block, but that didn't seem like a nice solution. So I changed my mind and I decided to make a block out of recycled pine wood or plywood I had laying around, just by laminating some pieces together. But then I realized that this motor is quite oddly shaped, because it's got 4 feet, as you can see here, but the motor doesn't sit directly on the feet. It sits on this belly, I guess. So I had to figure out another way to prop the motor up, and I came up with this frame structure I made out of pallet wood, and I bolted the motor to with 4 nuts and bolts and a few washers. Then I screwed the base, the frame from the base, and now this motor isn't going anywhere. Next came the wiring. The wiring was a little bit of a problem, but with a quick search on Google or YouTube videos, I understood how to wire the motor up, and I decided to wire it up to use the fast speed. As you may or may not know, washing machine motors usually operate at 2 different speeds, a slower and a faster one. I wanted the motor to work at the faster speed possible, and so I wired it up properly. As I stated before, this bracket was supposed to hold the capacitor, but I'm not able to use the capacitor yet. So basically this now serves just a as a bracket to hold the wire and prevent it from slipping out the case. Then I interrupted the live wire with a switch. Again, this switch is reclaimed as well. And finally I had to, this is the side that gets screwed here, and finally I get to make a hole right here for dust collection. This is a 35 millimeters diameter hole that allows me to connect the shop vac to the machine, and so the disc is spinning in this direction and the dust is getting sucked by here, and so it's not thrown around the place, and I hopefully will not be breathing that dust. Because, by the way, this machine makes a whole lot of very fine dust, and you really don't want to breathe that stuff and have it in your lungs. So the best thing to do is to either use a shop vac, always use a shop vac when you're operating this machine, or wear a good mask, respirator mask, or even better, do both. I do both. I'll explain you what I want to say, what I mean in a minute, when I'll give you a practical demonstration of how to use this machine. After making the case, I cut away this slot here to make room for the work table. I originally thought to make the work table tilting, but I changed my mind because I don't think I would be using that very much, and I can also modify the structure if I ever need to in the future. Okay, let's face the truth. I'm very lucky not to ever be going to do that. We all know it. So let's be completely true with each other. So I guess I've said it all. What else to say? So the disc sander, the sanding disc is an 80 grit sanding disc. I wanted to buy a 60 grit sanding disc in order to make it last for longer, but an 80 disc works fine as well, and I didn't find the 60 grit, so I had to be happy with an 80 grit sanding disc. Again, this is a 300 millimeters diameter sanding disc. It's self-adhesive, so I don't have to worry about how to how to glue this disc onto the platter. Every time I have to change the disc, I'll have to heat the glue up until it melts and then pull the disc away, clean the melamine disc that's under it, and then reinstall the new disc. So what else to say? Oh yeah, I was so good at making this hole that I basically chewed up my 35 millimeters Forstner bit, because I didn't notice that there was a screw coming up from here right in the center of this hole. And so when I drilled this hole, when I bored this hole, I noticed that the drill was finding it a bit difficult to getting into the wood. So instead of looking what was going wrong, I just shoved the drill into the hole, and that basically ruined my 35 millimeters Forstner bit. It wasn't that expensive a Forstner bit, but anyway, I'll try to resharpen it. So this was a little inconvenient that happened during the build. So let me give you a practical demonstration. I'll reassemble this quickly and I'll give you a demonstration of how this thing works and what fine dust it can produce. Okay, so here we are. I'm about to give you this demonstration of how this thing works. I will make this simple round off just to show you how quickly you can shape a piece of wood with a disc sander. But before I show you that, I want to dedicate a moment to explain why is the capacitor important. When I power up this thing, you will see that it doesn't start spinning. The disc doesn't start spinning because the motor alone hasn't got enough torque initially to get the shaft and so the disc spinning. The capacitor acts as a device that gives the motor that initial kick that it needs to go up to speed and to be fully operative. Furthermore, the capacitor also acts as a current limiting device because it limits the current that is flowing inside the motor, therefore preventing the motor from drawing too much current and to heat up and possibly burn. So basically I am hoping for the best, which means I'm hoping for the worst thing, which is burning the motor, not to happen until I understand how to use the capacitor. You will see me now power the unit up and start spinning, basically just jump starting the machine, because as I stated, it won't start spinning as soon as I flip the switch, as you can see. You see? The motor just buzzes because there is current running into its windings, but it doesn't start spinning. So I just give it the initial kick and then I power it up. By the way, I can also decide what direction to make the motor spin like this. Okay, I'll wear my dust mask right now and I'll give you a demonstration. This is real time. There we go. You can see how fast the shaping of this piece of wood was. Of course, it is a very rough surface that this machine leaves, because this is a shaping sander, it's not a finishing sander. So I'll have to buff it with my palm sander or by hand, and then I'll have to put a finish on it. But I reached the final shape of this piece in, I don't know, 30 seconds maybe. So this is why I wanted to build this machine, and I think I'll get much use out of it. It will be very convenient from now on. So everybody, thanks for watching, and I'll see you in the next video. Bye bye. Oh, by the way, you can see how fine dust this machine produces. This fine dust not only will clog your lungs if you breathe this, but it also tends to clog the disc itself. This means that you have to keep the disc clean for it to live longer, and for not having to change it every, I don't know, every use. So by keeping it clean, you basically unclog the crystals into the sandpaper, which will stay aggressive and sharp and will chew your wood up like nothing. How do you keep it clean? Just with an eraser or anything rubbery that you can just slide onto the disc while it's spinning, and it's going to clean your sanding disc in a second. Bye bye.